So the last thing in this, or not in this section 2.3, is I want to talk about graphs that could be misleading and also things you want to be careful of if you're making graphs. And what we call here are graphs that deceive. And the idea here is that you can present your information. There's going to be some accuracy, but you can choose a way of presenting that's going to mislead people. And there's two ways we're going to look at how that happens. So the first way is the non-zero vertical axis. So let's say we have some kind of times, and we're timing to see if, golly, well, let's say you're running across a parking lot, and these two people are going to have you time them. And, okay, so you're not running, they are. And the first person, if you represent their time using a bar graph or the bar graph, and then the other person's time you represent like this, you might say, well, okay, this is person one and person two. And you would say, well, it looks like the way you've presented this data, person one is twice as fast as person two. And then someone comes along and says, well, I kind of need to fill in the rest. I didn't put the numbers, but you know, I'll fill them in right now. And you say, oh, no worry, no worry. I don't need you to put in the numbers. I can tell clearly person one is incredibly faster than person two, or significantly so. And then they put in the numbers finally. And person one had a time of 40 seconds exactly. And person two had a time of 39.99 seconds. I mean, 40, they had a time of 40, 39.99, their bar gets to 30.99 on this graph. But you kind of see the problem here. 0 is way down here. If we actually draw this with 0, and you got to be careful too, you'll see some graphs that say, okay, well, maybe it's not drawn to scale. So 0's down here. Like, hold on. That distance, 0.01, a single hundredth, this is maybe 200ths if we keep things drawn to scale. Again, you got to be careful of this. If we draw things to scale and we include a real or a natural 0, what you're going to get, and you probably see what's on the way. I'll abbreviate this as person one, person two. Person one is exactly at 40, and person two, I don't think you can tell. And just to clarify, we might write the times above each bar. This was 40 seconds, 39.99 seconds. So who's really faster? Well, okay, person one apparently has the faster time, but if we're talking about 100th of a second, And let's say the person who's timing this is using just a stopwatch, not some sort of like laser that a person passes through. Or even with that, I mean, maybe if clothing sort of waft ahead of the laser for person one and there's waft a little bit farther, who knows? But the difference in these times seems almost negligible. It could be the result of human error. If there's using a stopwatch and a finger, there's a try to eyeball it and press. So suddenly person one and person two, they're pretty much going at the same speed. But in the other version, it looked like person one was twice as fast as person two. It's when you insist that you include a true zero and have everything done to scale that we really see the story that's going on here. So that's one way a graph can deceive. There's another. Pictographs. So let's say we say the wait time at Subway is 3 times as long as the wait time at McDonald's. Let's say that's what we have to illustrate. So the way I illustrate this is I draw a sandwich. And okay, I'll make it a little bigger. And some stuff in here. So a sandwich. And I'm going to make sure this is 3 times as long, about like that, as a French fry. So I've got my sandwich, I've got my French fry. So as we're looking at this, if I say to someone, all right, I'm going to symbolize the wait times of Subway versus McDonald's. This is the wait time for Subway, and that's the wait time for McDonald's. And you might look at these two pictures and say, oh my goodness, Subway is massively longer than McDonald's. Like, and what people might start doing is say the area, the size of this picture is so many more times bigger than this. It's like 15 times bigger than the French fry. So that means the wait at Subway is 15 times longer than McDonald's. Well, again, I was meaning to illustrate this using the lengths. So this is McDonald's, and this is Subway. So Subway is 3 times as long as McDonald's. But if you just look at the pictures and you didn't know that, it looks like Subway is a much bigger wait time. So you want to be careful with these. You could, again, mislead people into thinking that the Subway wait is much longer than the McDonald's wait. So again, it's a graph that could deceive. And so that kind of brings us to the conclusion of this chapter or this section. And the author gives some thoughts on things to consider when you're building your graph. So graphs use graphs for more than 20 pieces of data. That's the author's advice. The let's see. The graph is to draw focus to the nature of the data and not to eye-catching designs. So, and he also mentions that most of the ink should be, and he uses this phrase, use most of the ink, as it were, for the data and not design elements. Now, this, I did have a professor once who did seem to believe that you do have to add something to a graph to get people to look at it. If you have, and I hate to say it, it seemed like where this was going was if you have boring graphs, no one's going to read them. So if you're trying to communicate medical data or something very important to people, and they're just not going to even look at the graph, they don't get to see your work. You don't get to communicate what you want to communicate. Sometimes you got to have something to draw people in. So there is another side to this. At the same, at least according to, it seemed like a perception or a direction this one professor was going. There's a danger here, though. If you take artistic license, you might misrepresent something. Say, for example, you're doing some work for a farm. There's a specific kind of tree that has some kind of fruit or something. And what happens is there's a region, this is a region affected by drought, unfortunately, and this tree, if it, if you try to describe, the effects of the heights of the tree. So if there's not a lot of water, or the effect on the height of the tree. So if there's not a lot of water, it doesn't grow very tall. If there's some water, it does okay. If there's a lot of water, it takes off. And so you put your bar graph together, and you got this clever idea. Instead of drawing just bars, you do trees. So for the lots of drought or very little water, have this thin, scrawny tree that has like nothing growing on it. And then for the middle amount of water, okay, tree, it's got some things growing on it. And then for the lots of water, you have a big tall tree and there's all kinds of fruit growing on it. It's like, that's kind of clever. All right. And it kind of makes sense. I mean, if the tree is short because of drought, then it probably isn't producing other things if it's not producing height, right? And then, so you do this and you print this, and then someone sees this article with your chart, your graph, and they call in to your editor and they complain. They say, well, this particular species of tree, it will still produce fruit. It just won't get as tall and be as big to produce, but it still produces fruit. And your bar graphs give the idea that if it's not growing tall, that it doesn't produce fruit, and that's not correct. And then here's the thing. The reason you chose these scrawny trees because it seemed like good common sense. If it can't grow tall, this tree, maybe it doesn't produce fruit. And it turns out that's not correct. That was an assumption. It was artistic license that's misrepresenting what you're studying. Remember, you just studied the heights of these trees and their relationship to whether they're getting watered or not. You didn't actually look at the fruit output. So it's sort of a counter argument to my former professor. I would say you do want to be careful with artistic license and assuming certain things if you're getting fancy with your graphics. And that could cause all kinds of problems. So the author has these warnings here. Certainly, I think they're very valid. you will run into situations where they're going to, you might want to try to dress things up a bit graphically, but be careful. You don't want to misrepresent or make claims that aren't true. Anyway. Lastly, what the author mentions, and this we looked at with the zero or the non-zero vertical axis and with the pictograph. To some extent. Don't distort your data. You want to construct a graph that reveals the true nature. And again, with like the pictographs, the true nature is there. I mean, if you took the length of the picture of the sandwich and the length of the picture of the French fry, the sandwich is 3 times as long as the French fry, but it's not revealed very well because there's all this other distracting stuff like the overall size of each, the size of the sandwich and the size of the French fry that might distract you from just staring at the lengths of these two things. And that might not be revealing what you're trying to reveal very well. So again, you want to be careful. Anyway, that's it. If you have any questions about this, let me know.